Good morning, everyone. Very good morning. Shall we begin the session? In the last class, we have discussed with the basic data types and the user-defined data types. Now we have started with the chapter number 3, tokens, expressions, and the variables. And we have covered some parts, like for example, user-defined data types, built-in data types. Now, what is left with the data type is a derived data type. Let's start with that derived data type, in which it is a use. Yeah, my first question arises. Okay, alright, wait for 2 minutes more. Now the next topic is arrays. That is a part of the derived data type in which we are dealing with how various data types are derived or how various data types are derived from other data types. The applications of the array is similar to that of the C, but it is used in the different concepts like for output we use a C out, for input we use C, else everything is C. So when initializing a character array as SKC, the compiler will allow us to declare the array size as the exact length of the string consonant. For example, char string 3xyz is valid in an C that assumes that the programmer intend to leave out the null character in the definition. But in C++, the size should be one more or one larger than the number of characters in the string. This is the char string for xyz that is okay for C++. Now, that is the array. Next part is a function. So what is a function? That is a subprogram of the main program. So while some of the changes are simple, others also requires a new way of thinking when organizing our program. So this is the program. This is the scenario how we can use, how we can choose them. So many of these modifications and improvements were driven by the requirements of the object-oriented concepts of C++. Some are introduced via reliable and the readable. Some are introduced or features will be given that is given as a more reliable format. The next is the pointer. So pointers are declared and initialized as in C. This is the int asterisk or the int pointer. Then IP equals to pointer or % of x. That means address of x will be stored in the IP. Then the 10 will be assigned to the x to the in direction. So this adds the concept of constant pointer and also a pointer to a constant. So this is the char pointer constant ptr is stored. And we cannot modify the address that ptr is initialized to because it is used with the const pointer ptr that is a ampersand n. Where ptr2 is declared as a pointer to a constant, it can also point to the variable of the correct type, but the content of which it permits, it cannot be changed, it cannot be used as a, we can say the tool, because ptr is also a pointer variable that will be defined of the that data type only, that is a pointer data. And we can also declare the both the pointers and the variable as constant in the following way. Const char string const cp equals to x variation. The statement declares cp as a constant pointer to the string which has been declared a constant. And in this case, neither the address assigned, neither the content it will change. It will be changed with that will be a pointer. And pointers are extensively used in C++ for the memory management and achieving the polymorphism. They are the best part that will be used for the memory management and also achieving the polymorphism. Next is symbolic constants. What are the very symbolic constants? There are two ways of creating the symbolic constant. So first is using the qualifier or using the keyword const, then defining a set of integer constant using the enum keywords. So both C and the C++ are declared as a constant that cannot be modified by the program in any way. And there are some differences in implementation that will be used. So we use the const in a constant expression such as the cont int size 10 char name size. This would be illegal in C and that will be allowed to create the type constant instead of having the hash defined to create the constant that have no type definition, no type information. And as with the long and the short, if we use the const modifier alone, it defaults to the end. This is a const size is 10. That means it will be used as a constant that are just like the variable except that their values cannot be changed. This requires the const to be initialized. That will be the initializer. That if none of the given, that initialize the const to the 0. Yeah, constant. It is a constant value, that is 0. Now next is what is the scope of using the C or constant that is initialized. So a constant in C++ defaults to the internal linkage and therefore it is local to the file where it is declared. And inside C, const values are global in the nature. They are visible outside the file in which it is declared, and however they can be made local by declaring them as a static variable, because everything or every variable will be used as an external linkage so that it can be referenced from another file that must be explicitly defined it as an extern in the C++. So this is the extern const total is 100. Total is given as 100, that is a constant and that is the external variable. Another method of naming integer constant is by enumerator. So this is the enum xyz. So this defines the xyz as an integer constant with the value 0, 1 and 2. And this is equivalent to const x is 0, then y is 1 and z is 2. And we can also assign the value to the xyz with the enum x is 100, 50 and 200 that are declared as an integer value. Next is the type compatibility. Next one. Type compatibility, that is how one data type will be converted into another, depends on the requirement of the users. So C++ is very strict with regard to the type compatibility as compared to the C. For example, C++ define int, short, int, long int. There are different or three different types of files. They must be cast when their values are assigned to one another. Similarly, unsigned char, and signed char are considered as a different data types, although each of these has a size of 1 byte. That bytes or that types of values must be the same. That means when one byte or when one type will be converted into another, that must be of the same with that type compatibility. These values have been assigned for the complete compatibility or else a cast will be applied. And these restrictions in C++ are very much necessary in order to support the function overloading, where two functions with the same name are differentiated using their different argument list. Another notable difference is the way char constants are stored. In C, they are stored as ints and therefore size of x is equivalent to the size of int. Because we have declared the x as an integer type variable. Now next is how to declare the variable, that is the declaration of variables. So we know that in the C, all the variables must be declared before they are used in executable files, executable statements. That is very much true with the C++ as well. However, there is a significant difference between the C and the C++ with regard to the place of their declaration in the program. So C also requires all the variables to be defined at the beginning of the scope. And when we need a C program, we usually come across a group of the variable declaration at the beginning of each scope value. Their actual value usage appears anywhere in the scope, and sometimes it is used that is far away from the place of declaration. And before using this variable, we should go back to the beginning of the program to see whether it has been declared, or if so, what type it is declared. For example, if it is declared as a, so this is the int a, int b, where a equals to 10, b equals to 20. C++ allows the declaration of the variable anywhere in the scope. That means that a variable can be declared right at the place of its first use. That makes the program much easier to write and reduces the error that may be caused by having to scan back and forth. That makes the program easier to understand because the variables are declared in the context of their usage. Now this is one of the examples that illustrates how to make that point. It starts with the int main function, then there is a float x, float sum equals to 0. There are two variables that is declared. One is the x, one is the sum equals to 0. Then next is for loop that starts with the 1. I starts with the 1, I is less than 5, I plus plus. So it starts with the 1, go till 4 because it is less than 5, not equals to 5. Then C next, sum equals to sum plus x. Then float average, average is the sum divided by I minus 1. Then C out average. The only disadvantage of this style is that we cannot see all the variables used in a scope at a class because it is declared at bottom, it is declared at top. So it is better to declare each and every variable at the top. It is not that a program does not execute. Program execute, but this is not user friendly, we can say. Next is dynamic initialization of the variable. Yeah, dynamic means at the runtime, at the execution time. Dynamic initialization, that means we permit the initialization of the variable at the runtime. Variable is initialized at the runtime using the expressions at the place of declaration. For example, we use int n equals to str length string. The string function will be declared, will be used, or str length function will be used to count the length of the string. That output will be stored in the end. That gives a numeric value because it is of the integer value. In the same way, float area equals to 3.414, that is a pi into radius into radius. So both the declaration and the initialization of the variable can be done simultaneously at the place where the variable is used for the first time. And the first two statements are available as two parts, that is a float average, average equals to sum divided by I, that can be combined into a single statement. So dynamic initialization is also used in object-oriented language. We can create the object of any type that is made, that is allocating the memory at the runtime. Now next part is a reference variable. So C++ introduces a new kind of variable that is known as a reference variable. This variable provides an alias, that is an alternative name for a previously defined variable. For example, if we make the variable sum as a reference to the variable total, so the sum and the total can be used interchangeably to represent that variable only. That is known as a reference variable. Now how it is used, how we can give the name to the new variable or give the variable to the new name. Data type ampersand reference name equals to variable name. For example, we declare the variable float total equals to 100. Then in the next case, float ampersand sum equals to total. Now total is a float type that has already been declared. Sum is the alternative name given to the total to represent a variable total, and both the variable refers to the same data objects in the memory. Now the statement cout total and the cout sum both prints the value 100, and the statement total equals to total plus 10 will change the value of both the total and the sum equals to, or the sum to the 110. And likewise, the assignment sum equals to 0 will change the value of both the variable to the 0. And this reference variable must be initialized at the time of declaration that establishes the correspondence between the reference and the data object where it is means. Where it is declared, where it is important to initialize a reference variable that is completely different from assignment to it. Now, this next example is a variable x, that is alternative name given to the array element n10. This is int n10, that is an array. X is alias for the n10. Then initialize a reference to the literals. Now, the following are also allowed. Pointer is also allowed with the reference. And the first set of declaration also causes the m to refers to the x, which is pointed by the pointer p, and the statement that creates an int object with the value 50 and also name m. And major application of the reference variable is in passing argument to the function. So this is a void f int ampersand x. Void is a return type, f is a function name, and ampersand is the address that we are passing out. Then x equals to x plus 10. Int main int m equals to 10 f of m. When the function call fm that is executed, the following initialization occurs, that is the int ampersand x equals to m. Therefore, thus x become an alias of m after executing the statement.